Imagine waking up to a sky that seems alive, a continent where winds, clouds, and rain are constantly on the move, reshaping the weather with every hour. Europe is about to experience a dramatic dance of nature over 16th and the 17th of November, where powerful storms, relentless rainfall, and gusty winds sweep across countries, while mountains don their first heavy blankets of snow. From the bustling cities of Portugal and Spain to the high peaks of the Alps and the serene fjords of Norway, every region feels the force of this restless atmosphere. This is not just another forecast, it is a story of the sky itself, a journey through shifting pressures, roaring winds, and drifting snow that affects lives, landscapes, and the very rhythm of the continent. Stay with us as we explore every twist and turn of this dynamic weather, uncovering where the rain will fall heaviest, where winds will roar strongest, and where the first snows will make their mark, so you can be prepared, stay safe, and witness nature's raw power in motion. A broad and unstable weather pattern forms when several powerful atmospheric systems interact across a large region, each influencing the movement of moisture, air pressure, and wind. During mid-November, this happens as multiple low-pressure centers develop simultaneously across Europe, with one deep low spinning over France and northern Italy, while another weaker one lingers over western Russia. Low-pressure systems naturally pull in surrounding air, forcing moisture upward where it cools and condenses, creating widespread clouds, rain, and areas of snow at higher altitudes. When more than one low is active at the same time, their combined influence produces overlapping bands of rainfall that stretch across entire countries, leaving little room for stable or dry weather. Meanwhile, a strong Atlantic high remains locked near Iceland and the Central Ocean. High-pressure areas act as anchors of calm, sinking air, but their true strength lies in how they shape wind patterns around them. When a high of this magnitude sits next to multiple lows, the difference in pressure becomes dramatic. Air rushes from the high toward the lows, creating strong, persistent winds that help steer storm systems rapidly toward Europe. This setup tightens the pressure gradient across the British Isles and Western Europe, allowing frontal systems to move in quick succession and preventing the atmosphere from settling. Because the lows are drawing moisture from both the Atlantic and the Mediterranean, the air becomes saturated and rainfall becomes widespread and frequent. Regions close to the Mediterranean receive heavier downpours due to warm moisture, rich air being lifted into the colder system. Mountain areas begin to see snow as colder layers aloft interact with the moist flow. This combination of strong pressure contrasts, continuous moisture transport, and repeated storm development ensures that much of Europe experiences an unsettled stretch of weather marked by wind, rain, and pockets of high-elevation snow across the 16th and 17th of November. The heaviest rainfall develops where the strongest plume of Atlantic and Mediterranean moisture is funneled directly into southern and southwestern Europe, creating a focused corridor of intense precipitation. Portugal and western Spain lie beneath the core of this plume as a deep low-pressure system to the northeast pulls warm, moisture-laden air inland. When this saturated air encounters cooler conditions over land, it releases heavy rainfall in repeated waves. Cities such as Lisbon, Porto, Vigo, and Salamanca sit in the path of these convergence zones, where winds from the Atlantic meet shifting pressure boundaries, forcing air upward rapidly and generating prolonged downpours. Because the ground in many of these regions becomes quickly overwhelmed, runoff accelerates, raising the risk of localized flooding, especially in urban basins and river-adjacent areas. Southern France is affected by a different mechanism, but with equally intense results. Moist air from the Mediterranean surges northward and collides with the cooler continental air mass that dominates central France. This clash creates powerful lifting zones, particularly along the coastal ranges and foothills. As the air is pushed upward along these natural barriers, rainfall intensifies and becomes long-lasting. Regions such as the western Mediterranean coast experience these enhanced rains, where slow-moving bands deliver high totals within a short period. In areas with rugged terrain, steep slopes promote rapid runoff, increasing the chance of flash flooding and swollen streams. Northern Italy sits beneath yet another convergence of moist air as the large low centered over France begins extending its circulation eastward. The Italian coastline and inland river valleys collect moisture from both the Tyrrhenian and Ligurian seas, leading to heavy rainfall across regions such as Tuscany, Liguria, and Lombardy. The presence of the Apennines intensifies the precipitation further because moist air is forced up their slopes, cooling and condensing into heavier bursts of rain that steadily accumulate over the day. The frequent rain and strong winds experienced across the United Kingdom and Ireland come from a tightening pressure gradient created by the interaction between a powerful Atlantic high and several active low-pressure systems moving across Europe. When a strong high remains anchored near Iceland and the central Atlantic, its stable, dense air pushes outward with force. At the same time, deep lows positioned closer to France, the British Isles, and the North Sea pull air inward. The contrast between these opposing systems becomes compressed over the UK and Ireland, causing winds to accelerate significantly as the atmosphere attempts to equalize the imbalance. This results in persistent southwesterly winds that frequently reach speeds between 50 and 70 kilometers per h, are giving the region a raw, unsettled feel throughout the day. As these strong winds flow across the Atlantic, they scoop up large amounts of moisture from the ocean's surface and transport it directly toward the British Isles. When this moisture-rich air encounters the frontal boundaries tied to the passing low-pressure systems, it rises, cools, and condenses into widespread rain bands. These rain bands arrive one after another because the flow is fast and steady, leaving little time for the atmosphere to stabilize. Western areas such as Wales, Western Scotland, Northern Ireland, and Northwest England receive the brunt of this pattern because the prevailing winds first make landfall there, dumping their heaviest moisture on the windward slopes of hills and mountains. Orographic lifting intensifies the rainfall further, causing totals to build quickly over the course of the day. Despite the stormy conditions, temperatures remain relatively mild for mid-November. The continuous southwesterly flow brings air originating from the subtropical Atlantic, moderating daytime temperatures to around 8 to 12 degrees nights. Cool slightly but stay above freezing, adding to the overall sense of dampness rather than producing frost. This combination of steady rain, strong winds, and mild but uncomfortable temperatures defines the unsettled pattern affecting the UK and Ireland during this period. Heavy snowfall in the Alps and the high mountains of Norway develops when moist air from both the Atlantic and the Mediterranean is forced upward into colder layers of the atmosphere, triggering rapid condensation and the formation of snow rather than rain. In mid-November, this setup becomes especially efficient because multiple low-pressure systems feed continuous streams of moisture into Europe from different directions. Over the Alps, a deep low centered near France and northern Italy pulls warm, saturated air northward from the Mediterranean. As this air encounters the towering alpine peaks, it is lifted quickly to higher altitudes where temperatures are well below freezing. This process cools the moisture rapidly, allowing thick snow bands to form above roughly 1,500 to 1,800 meters. Because the system is slow-moving, the uplift continues for hours, leading to significant snow accumulation on the highest slopes, passes, and summits. The situation in Norway unfolds differently, but with similar results. Moist Atlantic winds strike the west coast directly, guided by strong southwesterly flow created by the contrast between a powerful high near Iceland and active lows deeper in Europe. When these moisture-packed winds hit Norway's rugged coastal mountains, they are forced sharply upward. Orographic lifting intensifies here as well, causing the air to cool quickly and release precipitation. In the lower elevations, this often falls as heavy rain, but in the highlands and interior mountain zones, temperatures drop enough to support widespread snow. Because Norway's coastal mountains rise abruptly from the sea, the lifting mechanism is strong, producing long periods of heavy snowfall in higher terrain, even while low-lying regions experience only rain. Both regions face travel disruptions as snow accumulates on mountain roads, passes, and high-altitude transport routes. Visibility drops in heavy snowfall, and rapid accumulation can make conditions hazardous for hikers, motorists, and freight transport moving across elevated corridors. As the atmosphere shifts on the 17th of November, a new surge of energy arrives from the Atlantic, while northern Europe transitions into a calmer and colder pattern under strengthening high pressure. A developing Atlantic low begins moving toward Ireland, pulling fresh moisture and increasing winds toward Western Europe. The pressure difference between this new low and the strong high building over Iceland and Scandinavia creates a powerful channel of southwesterly flow, steering another band of rain toward the United Kingdom and Ireland. Early in the day, skies remain mostly cloudy with patches of leftover rain from the previous system. But as the afternoon approaches, the advancing frontal boundary delivers a renewed spell of widespread rainfall. Winds strengthen as the front approaches, adding a renewed sense of instability and making conditions feel more unsettled across the western coasts and upland regions. While Western Europe deals with this incoming system, Scandinavia undergoes a contrasting transformation. As pressure rises significantly across Norway, Sweden, and Finland, the atmosphere over the region stabilizes. High pressure encourages sinking air, which suppresses cloud development and reduces precipitation. This brings an end to the heavier showers and persistent rainfall that affected Norway's west coast the previous day. However, the clearing skies also allow temperatures to drop more sharply, especially during the night and early morning hours. With colder air settling in, Sweden and Finland begin to experience freezing fog, widespread frost, and patches of light snow. These conditions form when moisture near the ground freezes in calm, stable air, reducing visibility and creating slippery surfaces on untreated roads. The combination of rising pressure to the north and an approaching low to the west creates a divided weather pattern across Europe. Western regions brace for increasing winds and fresh rainfall as the Atlantic system arrives, while northern Europe shifts into a quiet but colder phase, where frost, fog, and occasional snow highlight the arrival of deeper autumn conditions. A low-pressure system measuring around 999 HPA continues to influence a broad stretch of Eastern Europe, keeping the entire region trapped under cold, damp, and unsettled weather. Low-pressure systems naturally draw air inward, and as this air converges and rises, it cools and condenses into clouds, rain, and areas of sleet. Because this particular system is slow-moving, it maintains persistent cloud cover, allowing little opportunity for temperatures to warm or for the atmosphere to stabilize. Countries stretching from Poland through the Baltic states and into Belarus and Ukraine remain under its influence, experiencing long periods of light to moderate rainfall that often feels more like an unbroken drizzle than a passing shower. The air circulating around this low contains enough cold layers, especially in the northern zones, for precipitation to occasionally transition into sleet. This mix occurs when falling raindrops pass through a shallow layer of cold air near the surface, partially refreezing before reaching the ground. Northern sections of Poland, Lithuania, Latvia, and parts of Belarus become more prone to these wintry mixes as temperatures dip closer to freezing. Though not always heavy, this type of precipitation increases discomfort and can create slick surfaces on roads and walkways. The unsettled nature of the system also limits visibility, with low clouds hanging over cities and rural areas, creating gray, gloomy conditions that persist throughout the day. Because the low remains nearly stationary, the wind field surrounding it keeps feeding additional moisture from both the Baltic Sea and continental Europe back into the system. This recycling effect prolongs the wet pattern and prevents the atmosphere from resetting. Even brief pauses in rainfall are short-lived, quickly replaced by new waves of drizzle or light rain spiraling inward toward the center of the low. The overall effect is a prolonged stretch of chilly, damp, and uncomfortable weather across Eastern Europe, marked by steady precipitation, colder than average temperatures, and pockets of sleet in the northernmost regions. Europe faces a dynamic and challenging weather period through 16th and the 17th of November as a complex interplay of low-pressure systems, Atlantic highs, and moisture. Laden air masses drives widespread rain, gusty winds, and snow in higher elevations. From the heavy downpours of Portugal, western Spain, southern France, and northern Italy, to the persistent drizzle and sleet in Eastern Europe, the continent experiences the full spectrum of late autumn conditions. The United Kingdom and Ireland contend with repeated rainfall and strong southwesterly winds, while Scandinavia transitions from wet western coasts to calmer, colder, and frost-prone northern regions. Mountain ranges such as the Alps and the Norwegian highlands see substantial snow accumulation, adding hazards for travel. Across all of Europe, the interaction of highs and lows produces a highly unsettled atmosphere, highlighting the continued power of seasonal weather systems and the importance of remaining vigilant against flooding, wind impacts, and winter hazards at elevation. As this period of unsettled weather unfolds, stay safe, plan ahead for potential disruptions, and keep a close eye on local forecasts to navigate the conditions effectively. Good luck with your travels and daily activities, and thank you for staying informed and prepared through this forecast.